Let us take up next problem. A 220 volt 100 watt bulb is joined with a 100 volt supply. The power consumed by the bulb will be option A 50 watt, option B 25 watt, option C 80 watt and option D 100 watt. Let me teach you both the methods. Method 1 is the standard method or textbook method. What is the question given? Here, a 220 volt 100 watt bulb. First find out resistance of the bulb. What is resistance of the bulb? There is a relation between voltage, power and resistance of the bulb that is given by P is equal to V square by R. Therefore, R is equal to V square by P. What is V square? That is 220 square. 220 square divided by P. P is 100 watt. This is R. Now the question is, what is the wattage or what is power consumed with this resistance and supply voltage is 110. For that, we can use a simple formula, that is once again P is equal to V square divided by R. What is V here? Don't take 220, you have to take 110. That is 110 whole square divided by R, that is 220 square. R 100 will go to numerator. So what you will get here? 110 square by 220 square, that is 110 by 220 whole square multiplied with 100. So you will get it as 1 by 2, 1 by 4, that is equal to 25 watt. There is a shortcut for this. Whenever you are asked to find out power consumed by a bulb with given specifications, you can always use a simple shortcut formula like this. Power consumed, you can call it as power consumed, is always given by voltage supplied divided by voltage marked, or you can also call it as manufacturer specified voltage multiplied with power marked. That is, voltage supplied here is 110, power marked, voltage marked here is 220 square, of course, I forget to write the square, right, whole square into what is power marked in the bulb? 100. So that is 110 divided by 220 whole square into 100 will directly give you 25 watt. Therefore, option B, 25 watt is correct. Let us take up next problem. 5 conductors are meeting at a point X as shown. Find the value of current in the 5th conductor. Option A, 3 amperes away from X. Option B, 1 ampere away from X. Option C, 4 ampere away from X. And option D, 1 ampere towards X. This is a very simple problem. Observe carefully, this is based on Kirchhoff current law, that is 4 ampere plus 5 amperes is 9 amperes is coming inside this junction or node, and 3 ampere plus 5 ampere, 8 amperes is going out because you can see the direction, 9 is coming in, 8 is going out, therefore 1 more ampere should be available and it should go out and it should be away from it, therefore it is 1 ampere away, therefore option B is correct. You must know this, Kirchhoff current law says that this is based on Kirchhoff current law. Kirchhoff current law says, so current which is coming in, sum of all the currents which is coming into a node should be equal to sum of all the currents going out. next problem is based on the graph. The question is taken from CBSE PMT 2012. Cell having an EMF E and internal resistance R is connected across a variable resistance, across a variable external resistance R. As the resistance R is increased, plot of potential V across R is given by, you can look at the 4 diagrams here. Now, which among these 4 is correct is the question. Observe carefully. A resistance is connected to a potential of EMF E, voltage source of EMF E. The potential V in terms of EMF E and internal resistance R, and R is given by a very simple formula, that is voltage V is given by E into R divided by R plus R. Divide throughout by R, we will get it as E divided by R by R plus R. You can also write it as R by R. E divided by 1 plus R by R. Voltage V will never cross the value E. The reason is very simple. You have denominator greater than 1 always, because R and R both are positive, and whatever is the value of this ratio, denominator is greater than 1, means V should be always less than E. V should be always less than E. That itself says either A or C should be correct. And B and D are ruled out because you can see the relation in D, V is increasing and E is nowhere mentioned here. And here also, this may be correct. We can just think of this later. Now coming to A, C and B, which is correct? Observe carefully. E divided by 1 plus R by R. For the time being, assume small r is fixed, let us say 1 ohm. So what you will get here? E divided by 1 plus 1 by R. If R tends to infinity, denominator becomes 1. If R tends to infinity, denominator becomes 1. So capital R is infinity, that is external load resistance becomes infinity, then it will become 1. That means to say, if R goes to the upper limit, if R goes to extreme, then V becomes equal to E. This is possible only in this case. You can see here, if R tends to infinity, V becomes 0 here. So here R is never going to infinity, so you can straight away say that this is impossible. You are changing your resistance. You can increase your resistance to any value. So if you increase your resistance to a very high value or maximum potential of the decayed resistance box or potentiometer you have given, then only this suits well for the answer, because V becomes equal to E only when R tends to infinity. And one more thing, this line, this curve will never meet this line. You must have studied this in mathematics. This line is an asymptote to this curve, right? Even though it is not important here, you should be knowing about this. A line which meets the curve at infinity, a line which meets the curve at infinity is called as an asymptote. Now, capital E, this E is an asymptote to the curve of V. Therefore, only option C is correct. A is wrong and option C is correct.
CHIPS proudly announces admissions for crash course for JEE mains and CET coaching. Classes commence after 2nd PUC and 12th board exams. Crash course for 2nd PUC regular. Classes commence after 1st PUC and 11th board exams. Accommodation assistance provided for outstation candidates. Centers at Kumta, Dandeli and Bangalore.